the main spool. So we have some bevels to open and close ports in one movement. So a flow of oil is going to be moving the main piston or main spool down here. Okay. So we have then the housing. Inside the housing, we have the control spool, the main spool, and also the feedback sensor and some smaller pistons here. The red line is our pressure line. Remember from yesterday, so we have control oil pressure on our pilot valve. We have constant oil pressure on the exhaust side, and then we have working pressure in the center here for the working pressure, okay, for the movement. So a signal being sent to the pilot valve will move the pilot spool and allow control oil pressure to act against the control spool, moving the main spool up and down in this movement, this direction, up and down, to open and close these ports. Okay, so L, gentlemen, is for leakage. So L is for leakage. TFI is for tank fuel injection. CFI is for cylinder fuel injection. P is for pressure. CVA is for cylinder valve actuation. TVA is for tank valve actuation, and L is for leakage. So if you look in the chat, I have written the terms against the abbreviations or the acronyms, so you can have that for your reference. Okay, gents. So leakage, tank fuel injection, cylinder fuel injection, pressure, cylinder valve actuation, tank valve actuation, and leakage. We need to have the leakage lines for this internal leakage so we don't have a hydraulic lock. Remember, we are using system pressure, so as soon as it moves in one direction, we don't want it to lock there. So we need to have this internal leakage to assist the movement of the moving parts. So with the signal being sent to the pilot spool, sorry, the pilot valve, we will have some control pressure oil here, keeping the main spool in the center position. Center position means that we are draining from our exhaust valve actuator and also from our fuel booster. Okay. Any questions so far? Nope. So moving this spool, moving in this direction, so we can see that we have then a fuel injection will happen. So we're moving the spool in this upwards direction here. We are still draining from our exhaust valve actuator, and then we start to open this point here, where we then close the drain. So we're no longer draining from the underside of our fuel booster. Then the pressure port will open, giving us system pressure to the underside of the booster and then giving us the injection. Once the injection is complete, signal all the time being sent from the feedback sensor to the system and then back to the system giving us a control signal to the pilot valve here will move the position of the main spool to ensure that we are injecting at the correct time and the correct amount for the correct amount of time. Then when we have done the fuel injection, of course, there will be a movement of our pilot spool to allow pressure to drain away from the control spool um, um, control spool pocket here. And then we are having constant pressure on the top part of our main spool, and then we will be forcing this main spool all the way down to the bottom. Therefore, at this point in time, we will close the drain from our exhaust valve actuator, and we would then close the pressure port to the booster. Then we are draining from the booster, and then we would move it this way, opening the pressure port to the exhaust valve actuator, giving us pressure, giving us a full opening of our exhaust valve, and then we will be draining from the underside of our fuel booster. Any questions? The working or the expected service life for the entire unit is 32,000 running hours. 32,000 running hours, you will be checking and inspecting the mating surface of our pilot valve to the FIVA valve, and also the mating surface of our FIVA valve to the hydraulic cylinder block. You would take it off, you would replace the spool itself. So the main spool and the pin here is mounted together, and then the feedback sensor is zero calibrated. So the matching of the feedback sensor and the main spool can only be done by MAN, and only be done you can zero calibrate it on board, but we cannot pressure test it on board because of the hydraulic power supply systems in service not being able to maintain a specific pressure for a specific amount of time. Okay, we need to check the movement and the set positions of the main spool inside, and we need to have the pressure stable for a certain amount of time to confirm this. We cannot do it on board, that's why. So you can change the pilot valve, you can change the FIVA, including the feedback sensor, or you can change the entire unit yourselves on board. Any questions so far?
So after removing it, we should send it to reconditioning to MAN.
Well, 32,000 running hours is probably the same amount of time to your dock. So there will probably be a service engineer in the proximity anyway. So yes, we would either do it on board, or where we would take it apart, and then we would do the checks there, or we would put it to the workshop. Any other questions? Oh, what happened there? Okay, the movement of the FIVA. We have 4 positions in a fluid movement. So we can see here we have an exhaust valve operation, we have the neutral position, and the fuel injection. There is always a neutral before and after each point. So 4 positions